Right. Good evening, everyone. So the title for my talk is You Secured Your Code Dependencies. Is that enough? It's contrary to what you would have heard from everyone, where everyone is talking about source code and how you should be securing your source code. I wanted to talk about what are the other things that are there besides the source code that we most probably are just ignoring. So, a quick introduction about myself. I go by the title Chief Researcher. The perks of having your own company, you define your own title. So, I have a company named Cyfinoid Research. I call it as a research powered trainings based company. So, all the research work that I do, which is effectively all the time I spend Googling and searching around, I convert that into training material and I then deliver training at different conferences. About 17 years of corporate experience. I've been a trainer, speaker at a bunch of different conferences. I run a bunch of open projects, primary three of them, CodeVigilant. Effectively, I wanted to learn how to do code review. So I created a project and I used that to disclose bugs in open source software. Hacking Archives of India, because I realized not many people were tracking who in the Indian community is actually going out and delivering sessions. So Hacking Archives of India tracks all the Indian InfoSec researchers who are presenting in public sphere. Tamer Platform is very much focused around Android security. And across all social media platforms, except Snapchat, you can find me as Anant Shri, ANANTSHRI, and anantshri.info is my official domain. All right, so a quick question. How many of you have heard about these three terms? Software supply chain security. Nice. Software bill of material. All right. Source composition analysis tool. Some of you may know it by SCA tooling. Yeah. All right. So why all of this started, why we started talking about supply chain security, why we were worried about all of this. Somewhere along the line, incidences like SolarWind, CodeCov, Colonial Pipeline happened where the attacks happened not as a direct consequence, no one directly attacked them, but an indirect attack caused the catastrophe, which is where an executive order by US president was passed on. And in this particular order, SBOM was clearly mentioned. But what was also mentioned was that NIST need to work with the other US government entities to come up with a framework. And they came up with a framework. Now, supply chain security issues are not new. How many of you have been following OWASP for, say, more than a decade? You would have heard a name, usage of known vulnerable component. That is how OWASP used to denote supply chain security issues even before software supply chain security keyword came into the limelight. So the issue is not new. So far as this is the article by Ken Thompson, which I think he did somewhere in 1970s, 1983. That was the lecture that Ken Thompson gave about reflection on trusting trust. And they were talking about how a compiler can be backdoored to always have safe code, but unsafe binary. And the whole idea that they had came from a US military sort of paper that was written in 1970s. So this is not a new issue at all. This is a very old issue. And it's not going anywhere. EU, an agency in EU basically described it as this is going to be the topmost issue in 2030. So we're not even talking about 1 or 2 years, we're talking about a longer time frame. This issue is going to remain there. Across the globe, every government is coming up with something. There's a US regulation, there's an Indian regulation, Japanese, European, UK, every different region is coming up with different regulations. Most of them are effectively saying, have SBOM, maintain good quality hygiene about software development, and that's about it. Now, there's one part about why this is happening now. There's another part about how does the industry reacts to it. And there's a collective failure of IT industry We do what is bare minimum necessary to be done to get by. And what is asked of us? Create SBOM, follow standard coding practices. So whatever is the bare minimum, if the requirement is 80.000, we will not do 80.001. We will just do what is bare minimum required. So people are creating SBOM. Now there is very much difference between a good quality SBOM versus the SBOM that someone is creating. But having an SBOM does the check mark, so people are happy with it. Now, why this is happening now, why software supply chain is a bigger problem for us now. One, we started with automation of systems. DevOps came into picture. When DevOps and Agile came in, we had rapid build cycles. Now people are able to build softwares faster because the entire process is automated. What happens when you have rapid build cycles? You're able to deploy to production faster. I know of organizations who can actually deploy to production 40 to 50 times a day. We're not even talking about a week. Within a day, 40 to 50 times they can make deployments. When that kind of a rapid process is there, the development pace is also rapid. What that then means is I am less inclined about maintaining my tech debt. I am more inclined about releasing features. When I'm not inclined about maintaining my tech debt, I would try and find other pieces which I can source in, which is where now the stats say about 80% of our code is actually import statements. We're just borrowing code from other people and then using them in our systems. There is obviously an advantage of it because one particular project, if maintained with good quality, can help thousands of projects not to repeat the same set of mistakes. But if that one project, and how many of you here deal with NPM ecosystem, Node.js ecosystem? So less people, so bear with me those who are from NPM ecosystem. There's a module in NPM called isEven. It takes an input as a number and it tells you whether it's an even number or an odd number. There's another module called isOdd. What do you think is happening inside isOdd? It is importing isEven and telling you the inverse of isEven's output. So when you have modules like these, then there is some sort of a problem that is going on. Now, we build automation. We've done a lot of automation. How many of you have used Dependabot? So GitHub, if you've used GitHub, has an internal feature called Dependabot. It's a product that they bought in and then made an integral part of it. If you have a software product in your GitHub repository, you can enable the dependency check and it will automatically create pull requests for you whenever there is a security update that is pending in your project. So it gives you guidance that, yes, there's a security update pending, you should update this, and then you can have a secure software. So where are we in terms of numbers? So I took a snapshot around start of February 2025. I can't even count this in numbers. So start of Feb, end of June, these are the numbers. There's about 1,20,000 new issues that are created. There are about 24,51,000 issues that got closed during this time frame. An issue being closed does not mean it got fixed. It could simply mean that I went in and closed, select all, close the issues. That's also a possibility with a closed issue. So Dependabot and all these systems that are there. So Sneak does some things. There are SemGrep has some similar module. There are a bunch of other product companies that do something of this nature. They inform you that your software is vulnerable. Problem is, I have one software version today. By the time I have merged it after testing all the things, there is another version out, which again has a bunch of security fixes. So I am in that constant wheel of just updating. And at one point, my code stops working because there is a breaking change in my dependency. And that's kind of where the developers are like, To hell with it. I am not updating. Whatever I have works, and that is going to remain as is, which then becomes a problem for the security team. Now, software bill of material, I used this word earlier. Consider when you make a recipe in your kitchen, you have a list of ingredients. Consider that same set of ingredients, but for a software. The number of products that you're importing into your software, those are ingredients that you list in software bill of material. These are dependencies that your software has. Now, SCA or source composition analysis tools, they actually take this input and then they give you details. Details like how many of the softwares are outdated, how many of them have insecurities in them, how many of them are end of life. Now, end of life, anyone has used this term or understands what this term means? I am still struggling to figure out what the right value is. An end of life of a product could mean that if it was my software, I've stopped working on it. It could mean that I do not care about security issues on it. It could mean that I have died and there is no one to support it. It could mean that the company that created it got bankrupt, got taken over, got into a conflicting zone, so they're not able to support it. End of life is a very tricky term, but effectively, if the module that you're using is not supported anymore, that's where you classify it as end of life product. Now, how many of you have SCA toolings? There were few hands about SCA. So you have some sort of an SCA tooling in your environment. And obviously the output of these SCA toolings would be piped into a vulnerability management system of some nature, which is where you track and then you keep on tracking and keep adding new issues in. This is a very much, say, management term. But anyone here who has seen this Johari window? So this talks about what is known to you and what is known to others. What is unknown to you, what is known to others. But the important piece is that red block. Neither known to you, neither known to others. So we're going to start looking at some of the things which you should be worried about, but we are not aware of. So software supply chain, when anyone talks about this term, they're generally talking about the dependencies that you have with your source code. Now, I consider a lot of other chains in the picture. Anything in your environment that has plugins that you can pull in, anything that you have in your environment which allows you to customize via importing third-party developed code, all of that becomes problematic element for you because they can induce insecurities into your environment. So I used this statement about a few months ago. I want all of you to read it. And those who are in the corporate world, think about how many of these items can you right now track and are aware that these exist in your network or in your environments. So a developer uses a Chrome extension to manipulate an AI prompt, which are then fed into Visual Studio Code through a set of AI-driven code completion extension. The resultant code gets to GitHub. Then a CI kicks in, which is GitHub Actions or any other CI in this case. The final code via CD gets into a container environment. Now this containerized image gets deployed over Kubernetes cluster, which is running over EC2 instances created using the AMIs that you have cooked. How many of these highlighted entities can you right now feel comfortable about your environment that, yes, I am aware of 60% of them, 80% of them? How many of you can say, I know everything in this set that is available in my environment? Can anyone claim that? About 50%. Container images, how many container images you have? How many code repositories do you have? So this was 5 months back. What we have now is more fun scenario. We have autonomous AI agents, which are running in our developer machines with full access to command line, which means they can run curl, they can run wget, they can run those in Mac, brew installs, those on Windows, chocolatey or wget installs, those on Linux machines, sudo apt-get or sudo rm-rf, whatever they want to run. They can run all of those with full access to your command line. Again, the remaining part still remains the same. You involve a code repository, you have a CI system, you have a CD system, then you have the artifact stored somewhere, and then that artifact gets deployed somewhere, and the whole process goes on. Now, a simplified view of supply chains that we should be looking at for me is this. There are dependencies pertaining to development environments, code repositories, CI/CD pipelines, container environments, deployment and cloud environments. Now, why do they matter? Your production is where you have deployed every single precaution that you can think of. Outbound connections, I don't want them. I want to monitor everything. I have all sorts of protection. But on your developer's machine, you have the AWS credentials stored in .aws/credentials. You have the SSH key for production, most probably named as .ssh/id_RSA. Standard names that developers will have on their machines. And those are the files that are tricky, that are very easy to get for an attacker if they have access to the system. They're tricky to identify where what went if you are just looking at it from external log perspective. Now, developer machines, like I said, lots of credentials are going to be there. You have to relax security for developers. You want them to have certain level of access. You can't block all access from developers. So the developer machines need to have larger level of access. A lot of them. So check. How many of you have developers in your environments who have admin access on their machines? So admin access on their machines means they can install anything. All sort of interesting stuff can go in there. In production environment, there's always a check that admins do. Do not install debugging tools. Do not install compilers. Anyone who has done hardening of production environment, these are the two things that you don't install. And these are the two things that you definitely need on a developer machine. So I have everything I need to even go as far as download my code, compile it locally, and then run it. Now, examples, because I've been talking for a while. This is what you see is not what you get. In red, I have given a URL. If you open that URL on your browser, you'll see a statement. There's a bash script which will say, I am legitimate. If you do a curl and then pipe it to bash, you will get a statement which would say, I am evil. Because what I've done there is, on the backend, I have, based on the user agent string that is requesting the URL, I will change the content of the URL. So when you open it in browser, where you're verifying it, you see something. But when you download it, you get something else. Now, this is not just one example. There are a hell lot of examples that are there where curl pipe bash, curl pipe sh is a problem. And multiple people have done this attack to a level where if you go into don't pipe to your shell, these links, they will give you a prompt where you will have a text. You copy that text. The text would be there, followed by a pipe bash script, which will execute. So as soon as you copy it, paste it into your terminal, a command gets executed automatically. Now, where does this get used? How many of you have used Oh My ZSH? I am assuming this is how you have installed it. Copied a line from OMIZSH official website, piped it to bash, and that's how OMIZSH got installed. This is the standard way by which the installation happens for a lot of these customizations that developers love, because they give extra features, they give extra capabilities. Chrome browser. All of you have used Chrome browser. One of the reasons why Chrome got famous, besides the speed part, was that it didn't require admin access to install it. You could download the installer, run it. Without admin access, you can install it as a local user. That was the key, one of the key criteria which made Chrome far more usable. Now, what happens with Chrome? So 33 malicious extensions. What can an extension do? So there's an extension which is an SSH agent. It allows you to use SSH within the web browser. There's another extension which is an HTML5 file system which allows you to explore the entire file system of the device where your browser is running. So your Chrome extensions now have capabilities to look into your file system, to look into external connections. We now also have web APIs. So web USB API, web Bluetooth API, which allows your browser to interact with hardware. If anyone has recently bought a Pixel device, and if you have ever reached a point where your Pixel device is causing problems, you can now go to android.com and there's a direct flash firmware option where you connect your device to your laptop, and from the browser window itself, you can flash a firmware. That's the capability browser has. Whatever capabilities browser has, extension gets those capabilities by extension. Cookie Monster. This was a extension which was basically just stealing cookies. Very age-old stuff. I think anyone who has been in the naughty times of hacking would have stolen cookies from other people. When SSL does not used to be the default, Wi-Fi, you just sniff out cookies. So cookie stealing is very age-old game. Visual Studio Code. How many of you use Visual Studio Code? This is an example of a Visual Studio Code extension page. Now this has a name of the extension, GitHub action. And below that name, you see a name of the author. And right below that name, you see a blue checkbox. What are we conditioned when we see a blue checkbox? This is a verified account. Twitter has convinced us about that. It's a verified account. What does verification means in this context? In this context, verification only means this user owns the domain that is mentioned along with it. That's it. Nothing else. There is no verification, no validation of the extension itself. It's just a verification of this user owning this domain, which is nowhere related to GitHub Actions. But it's there. And a lot of people might get fooled considering this as official extension. Visual Studio Extension Marketplace, which is where you download the Visual Studio extensions. Now, any IDE which is not created by Microsoft, which means your Cursor, your Windsurfs, and all these new IDE breeds that we deal with, which are based on Visual Studio Code, they cannot use that extension marketplace. That's the agreement that is there, that the official extension marketplace can only be used by Microsoft products. So now what came as an alternative is openvsx.org. And the link that I've listed here is, I think, about 6 hours old. 6 hours ago, this disclosure came out that there was a marketplace takeover available where, because of a malformed CI system, the attacker was able to get a token which allowed them to update any extension in the marketplace. And what happens when an extension gets an update? Most of us have Visual Studio Code ISC tool configured to auto-update the extensions. So the malware spreads on its own as soon as the update gets in. Homebrew. Anyone with Mac environment, if they have any inclination towards development, would have used this. Anyone who has not used it, people in your company would be using it. Because you cannot do development work in Mac if you do not have Brew available. This gives you the lifeline. Now, Brew, very recently, there was a Google ad that came up which pointed to brewsh.org. And if you see brewsh.org, which is not the official website, it had a script pointer. And this script, when you execute it, it gave you a prompt which asked for your sudo password. But it was not the system prompt. They were capturing that password and then using it internally to spread around. Linux machines. So why should Linux be behind all of this? So RPM, deb files. If you have sudo rights given to the developers to install RPMs or deb files, which can be downloaded from random sources and installed, they have pre, post, and uninstall and post uninstall scripts, which get executed, as the name say, before installation, after installation, before uninstallation, after uninstallation, and you can have whatever code you want to put in. So my pre-install code would be put a backdoor here. My post-uninstall code would be put a backdoor here. Pre-uninstall, check if the backdoor exists. If it does not, put the backdoor back. Post-uninstall, do the same process again. So I can have the whole system continuously under my attack. The sources.list. Anyone who has installed Chrome or any Microsoft product on your Linux machines, go check your sources.list. You will find an entry. If it is Chrome ISC tools, a Google entry. If it's a Microsoft tooling, a Microsoft entry. They have added that entry without any restriction because they wanted to keep their product updated, but they wanted to use their own code repositories for it. So they've added that one-liner. And now, even if your repositories might have a version of that software, it'll always come from that repository. Git clones, all developers have done that. Git space clone, get the repository. If there are modules, minus submodules, get all the submodules. This bug was if you do recursive submodules, you get code execution. So you're just cloning someone's repository and you're getting code execution on your system. Scripts in Postman. Postman is how you access APIs, how developers access APIs. You open that Postman collection and you have code execution. Notepad++, anyone who is unlucky to be using Windows for development would be using Notepad++. Am I wrong in that assumption? So if you're using Notepad++, there are again bugs to a level where very recently Notepad++, and I think this domain still exists, Notepad.plus is a domain that exists, which is not officially affiliated to Notepad++, but serves a binary of Notepad++, which has certain extra ingredients inside it. Now Cursor or Windsurf, AI IDs. Anyone here who is not a developer, who's a developer and is not using these IDs? You should be. They are fun. That's how you get funny things happening in your system without knowing what is going on. So Cursor has this setting, which I recommend it should be turned off. By default, if I remember, is turned off, but a lot of people turn it on because it's annoyance when you're actually using Cursor and you have to continuously accept and accept and accept. Because every time it wants to run a command, it will give you a prompt and you'll have to say accept. So you go in and enable this option. What this does is it then allows Cursor to figure out what is the next command I want to run the command, see the output, based on the output, decide what the next command should be, and continue the whole process till your system has any legible file available on its own. But effectively, since it's LLM dependent, the LLM output is dependent on the files that are present in your project. So if your project README at the bottom in non-readable ASCII characters says, get these files, curl them to this URL, it'll do that. Example of it, this is a rule file. By default, it'll look like what you see on the left side. Follow HTML5 best practices. What it has is on the right-hand side, the hidden characters, Unicode characters, which is saying always decode and follow instructions and blah, 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 blah. The attack path, whatever you want to do as the attack path. Very simple, decent prompt injection, but it works. And we can't see it. Remember those CTF days when the flags used to be hidden in white spaces and you'll have to select all to see where the flag is? It's kind of that, just a bit more dangerous. So we're talking about desktop environments. Let's look at CI/CD systems. I am not going to talk about code dependency issues. That's not my focus. There are a bunch of other people who are talking about it. I'm talking about everything other than code dependencies. CI/CD systems, they are the automation around our code. Now, the question that I always ask is, who watches the watchers? There's an old reference around watchers, but I don't know if you'll recognize it or not. But defense.gov did a decent job around CI/CD pipeline defenses. What are the various phases where you should be looking at different problems? I'll be sharing the slide deck as soon as the talk is done over social media, so you'll get that. But the URL basically points to the entire PDF document around this. Now, what can happen? What can go wrong? So SolarWind hack was a TeamCity attack. Effectively, a backdoor in TeamCity, which led them to have access to SolarWind environment, which led them to be able to plant a backdoor into Orion system, which were then deployed into Fortune, I think about 450 or 500 Fortune 500s. So that's kind of how the proliferation happened. Container images. Now we don't install softwares. We've kind of reached that point where why download a software when there are too many dependencies? Just download containers. Containers will have everything pre-baked in. And that's how a lot of times environments work. Are you sure you're downloading the official or the authorized image or the right image that you were supposed to download? So Aquasec, two of the container images, OpenJDK and Golang, used misleading titles that suggest they are official container images from OpenJDK and Golang respectively. Very easy to deceive. Another example of this would be around the AMIs, where if you go into Google, AWS AMI screen, where you're searching for AMIs, and you give partial name, there'll be multiple AMIs that will pop up. You have to decide which one is the one that you want to use. Some would be from the official source, some would be from some known developer, some would be from unknown places. A lot of times the criteria to download is which has less size, which has more stars. That's kind of how we judge things. Now, dependency caching is where your GitHub-like environments are continuously downloading dependencies from servers. So they don't want to keep downloading and choking the bandwidth. So there's a caching layer in between. What if you can poison that caching layer? So the official site has the right software. The caching layer at the GitHub action side is poisoned. So you will always fetch the poisoned version. So this talks about those attacks. Now, bait and switch. This is a practice that has been followed for a very long time in two different modes. One, Someone has intentionally created a package with an idea that at a later point, I will switch to a malicious entity. Or two, someone had good intentions. They created something, they could not sustain it. So they either sold it off or gave ownership to someone else. And then a malicious entity came into picture. So this is an example of WordPress plugins. Now, WordPress plugins by nature are very auto-update-ish right now. So this company used to purchase WordPress plugins which were not updated for a while by the developer, claiming we will maintain the updates, and after a while put a backdoor in. And this would auto-update, and every site that had that plugin would have the update in. These are bunch of different rogue maintainer scenarios. One scenario where, and again, when I say all of these scenarios, start thinking of it from your organization point of view. How fun it would be if such an incident happens in your organization. When Russia and Ukraine war happened, a maintainer decided that it is wrong on part of Russia to do what they're doing. They added a check in their package that if you access my package from Russian IP address, I will start deleting files on your system. There was once a package where the package maintainer had been begging people to help him, support him. They did not. So one company which was using that package to create a commercial product, they asked, hey, you're using this for commercial purposes, give me something back. At least give me sustenance money. That's what I'm looking for. Did not happen. They pulled that package out. Nothing major happened. AWS CLI stopped working. There were a bunch of about 20, 30,000 high profile NPM packages that stopped working because this package was used by all of them to generate fake data. So now NPM restores that package saying, hey, this is wrong. You can't pull a package which is a core dependency for these many products. So this developer in anger removes all of his packages, and he had, I think, 300 packages in NPM repositories. So far more number of packages have stopped working. Again, NPM restores all of them. And again, a whole conflict keeps on happening, like who is right, who is wrong. Because then they agreed, okay, yeah, I'm going to publish the right package back. They added the package back with a time loop. So it will not run complete at all. It'll keep on running in loop. So what do we do? The gloomy pictures are all fine. What do we do? Doing a lot of talks for management folks have kind of conditioned me to give them some sort of an acronym, because that's how people remember. So this is the acronym, ATOM. Have awareness about your environment. Trust, but verify. Try to do verification. Do ongoing monitoring. Measure and map. There's a keyword that comes up very often, observability. Do you right now have the capability to ask any system in your environment a question? Let that question be, how many of my systems have log4j.jar? Do you have that capability right now? If you have, it gives you an edge. If you don't have, just for fact's sake, IBM took 45 days to give back a confirmation on how many systems they had which were vulnerable to log4j attacks when log4j attack came out. That's because they had such a vast empire of softwares. So if you don't have observability around it, that becomes a problem. Now, no matter how many examples I give, whatever I give as resources, they'll not be enough. There are a bunch of resources that I do wanted to quickly touch base on. First is this Chrome extension auditing. There's a site called extensionauditor.com. You can go there, you can actually check for your Chrome extensions. And it'll tell you what kind of permissions your Chrome extensions require. Is there a known vulnerable or known malicious entity within this particular extension pack? OS query. How many of you have used OS query? So this is an OS query which can tell you all the Chrome extensions that have clipboard write capability from all the machines that have OS Query installed on it. Not 100% foolproof solution, but it gets you started. If you have OS Query available on all of your corporate assets, you might have the capability to make this kind of queries, make these kind of calls. Now, GitHub and GitHub Actions, these are basic common sense things which are uncommon. You don't find these in most of the organizations. Signed commits. How many of you use signed commits? How many of you use signed commits with SSH as your signing key? How many of you use the same key for logging and signing? So SSH or GPG, these are the two options for signing a commit. When you make a commit, okay, dial back a bit. Git, which is the core for GitHub, has a very unique feature. You define what is the username that you want for the commit. You define what is the email ID you want to put in the commit. So I, today, can make a commit as Linus Torvald, and his name would appear on my commit history, that this commit is made by Linus Torvald. Now, the only protection that you have against it is, if you add a signing key into your GitHub account, and while doing signing, and I think similar process exists for Bitbucket, GitLab, and other systems also, if you then sign every single commit that you make using the signing key, you get a verified tag in front of your commit, which confirms that, yes, this is a verified commit. This is coming from the person who is named here. The named person and the signing person are the same people. Now, the problem that comes with that is people want easier stuff. So SSH is allowed for login. SSH is allowed for sign in. So I will use the same SSH key for signing and logging in, which is again an insecure practice, because if one key is lost, both of the stuff is lost for you. Protected branches, where your main branch or master branch does not get auto commits or cannot be force pushed into. Only the admin can force push in. Otherwise, everyone else has to create a pull request. This is again a setting that a lot of organizations don't do. Forced review for pull requests. So at least one person or two people have to review it. If you have a process where one person can review it, contact me later. I'll give you a GitHub action which kind of bypasses that by becoming the reviewer who auto reviews that one review. And then you can get the commit in. Tooling wise, there's Legitify. Legitify is good for your GitHub environment configuration. For each repository, if you implement All-Star, which is by OpenSSF, that's a good option. And ZIZMOR, this is for GitHub Actions. It helps you check the GitHub Actions if they are in the proper order or if there is insecurity inside it. This is a tool for your packages. Tool's name is safedep.io. I think you can get the details from this site. The tool's name is VET. The reason I'm talking about this, and a lot of tools in a similar manner would start appearing now, they allow a policy engine in between. Because the definition of a good package is different for different organizations. For me, the good package might be 10 stars in GitHub, 2 commits, 2 different committers. That's good enough. For a high profile environment, it might be that they need at least 100 stars on the repository, at least 10 active contributors to the repository to be considered good enough to be included in my project. Whatever is the customization you want. For me, GPL2 is fine. GPL3 is fine. For a lot of corporates, that's not fine. I don't want GPL anywhere in my corporate code. That's how most of the corporates would act. So you can have all of those in the policy engine. Now, there are again a lot of browser overlay softwares. This is good for developers. So developers can have these Chrome extensions, which will give them overlay when they go to npm.js or they go to the Chrome extensions repository. Sneak Advisor or socket.dev, deps.dev, they'll give you details about that particular package, whether that is in good books right now or not, if there are known issues around that particular application. Now, these are a bunch of different cloud auditing tools. If you are looking at cloud environments, Scout Suite is a Swiss Army knife sort of tool. It does AWS, GCP, I think Azure, DigitalOcean. I think it has Linode support also, but at least 3-4 top tooling. Prowler, I made a mistake there. So that's not Prowlet, that's Prowler. The Prowler tool again is an AWS tool. A bunch of different, anything that starts with KUBE, I think you would have guessed it's around Kubernetes. Then you have Trivy, which is for container environments. You have Cosine, which is basically for provenance purposes. Now, there are a couple of more references which are further study material. What I gave you as a view of software supply chain was still a bit confined view. This is a view from Secure Stack, which is a more broader view of software supply chain. You'll see right from people to cloud, every single section has much more detailed bifurcations here. This is SLSA, which is the Google and a bunch of other companies have come together and created this software level of software, supply chain level of software artifacts, or SALSA. Now, there are a bunch of different levels. Anyone who has worked with OWASP security verification standards, you would be familiar with levels. So they again have levels in them. Level 4, I think, is the level which is considered aspirational, non-achievable, because the requirements are you should have reproducible builds. And Debian right now is struggling with about 80% of their packages in reproducible level, not 100%. So reproducible build itself is a problem right now, and bunch of other requirements that they have. Now, what they do is they take a producer to a consumer cycle, source, build, distribution, dependencies. In each of the junctions, what could be the problems and how do we deal with it? Now, OWASP had SCVS, which effectively got a lot taken into SSDF. Now, what I loved about SSDF, and anyone here from compliance world? Okay, 1%. You would love this. What they have is, they have requirements, and then at the end, they have references to other compliance standards, line item numbers. So if you are compliant to any of these line item numbers, you are compliant to this requirement. This is something that I expect every compliance framework to have, because if this is there, we have a better way of getting faster compliances because we could map things together. Now, pbomb.dev is another site which is again trying to do more around supply chain security. They have come up with a framework called OSCAR, Open Software Supply Chain Attack References. Now, what they've done is they've taken MITRE attack framework and in similar lines, bifurcated all the attacks that can happen in supply chain security world into different sections. So you can see reconnaissance to lateral movement, all the items are displayed here. What I'm not going to touch, and this is going to be the last slide, I am not going to talk about SaaS. That's a can of worm. Not going there. I am not going to talk about Internet of Things. Another beast altogether. I have touched a bit on AI, but I think the next speaker would do more AI stuff. That's all that I had. I do not have a lot of answers. I have a lot of questions. Questions that you all also need to start thinking. I am also thinking about what could be the solutions, but more so, do we even want to go in that side? But yeah, I'm open to any questions if there is time.